In this video, we're gonna construct the model that we now demonstrate, which has a single class with two integers. Every time we run it, I just want to double check that I can validate it and there's no errors. To run it, I have a debug configuration. The first part we're gonna watch is the loop behavior. You can see here setting up the initial variables. Calls a function here. When that function is completed, it moves on. Now we're stuck on that function because I have some breakpoints. I'm gonna take them all off. I'm gonna resume the execution. Let me go to this model just to show you that we go around and this function gets called. In this function, we add the previous and the next value. Now I'm gonna pause it, put all the breakpoints and run it. And if we stop at the very first breakpoint, if we look at the first variable, it's currently 2, it was 1. The other variable is currently 3. So we'll run it again. Disable most of the breakpoints and just keep 1. When it stops here again, about to add, you're going to have a look at the context. The previous is 3, the next one is 5. The previous and the current Fibonacci number. Let's run again. We're going to look at the values. Previous is 5, the next Fibonacci number is 8. Let's do one more time. So 8 and 5 is 13. If we look at this Fibonacci, the previous one was 8, the current one is 13. So let's build this behavior. File, new Papyrus project, next, Fibonacci synchronous. I'm going to do a new Papyrus model. We're going to call it Fibonacci synchronous. This guy we can actually delete. We're going to open. And we're going to do our very first child package. Fibonacci package. A new class diagram. Active class diagram. A class, we bring it here. It's going to be an active class. Therefore, we click here. We're going to add some properties. The first property, Fibonacci current. The type is going to be, or primitive types, an integer. I'm going to make it private. And again, same kind of thing. Add a property. Fibonacci. I'm calling it previous. It's also going to be an integer. Also gonna make it private. And we need an operation. Increment Fibonacci. One important thing here is in our package, we're gonna import a registered package, and that registered package is gonna be the functional model library. Now we bring all the integer functions. Now in our active class, the new child as new behavior, we're gonna call this increment method. Save all. This method is going to have a new diagram, an activity diagram. We're going to call it increment activity diagram. Reproduce our diagram before. We need to read ourselves read self action. So you click, it comes here. We're just going to call it this. Split that into a fork node, and I'm just going to call it fork node 1. And notice that I can already make an edge. It's going to be an object flow. Object flow 1. I'm going to do validation of validate model. Here we have some errors. We go to our class diagram. We see that we have a couple of errors here. The first one has to do with the increment method. We go to class, advanced, add a behavior here, a classifier behavior, by adding the only one we have so far. That is our increment method. File, save all. This doesn't update in me, so that's why I close that. Validate model, and I still have error here. So an active class shall have a classifier behavior. This guy is the one that doesn't have a method. Let's go at the properties UML of the increment Fibonacci. We don't have a method, and we're going to add the method 5, save all, validate model. Nothing comes up that, but you can open it and we don't have an error anymore. Building here, or activity diagram. Notice that here we had a structure that is a read self action. We want to extract from it. We want these read structural feature action. From the object, we're going to extract one of the attributes. We go to properties, read previous. We're going to have an object flow. Object flow 2. This guy needs an output pin. New child output pin. I'm going to call it output pin. So we need to actually read something here. The structural feature. Track the previous. This is good to do regularly. Validate model. Nothing comes up, so we're good so far. Now what I'm going to do is copy this guy. So edit, copy, edit, paste, read current. Change this part here. Change that to the current. Object flow 3. Add call behavior action. The behavior that we want is from the foundations library that we imported, an integer function to add. We're just going to call it add. Connect this result to x, integer flow 1, from here to y, integer flow 2. Ready to add two numbers and store them in the current values. We need an add structure feature action. Set current. And we're also going to need an input pin. What object? An object flow from here to here. Object flow 4. And now we need also an object flow. The result of the add should go into the input pin. Integer flow 3. If you know a bit of the routine, we go validate model, and we get a lot of little errors here. Let's have a look at the properties. We don't have what is the structural feature that we are updating. We're setting current. Close this. Validate model. Errors, what we're going to do is change this, go to properties. I'm going to call it value. Validate the model, and we have a few less errors. There's an issue here about the bound. Upper bound, we're gonna make it literal integer 1, validate our model, and we have no more errors. I'm going to do the same trick as before. Since this good fabricated component, I'm going to copy it, paste for it, set previous. We need to update the object, so we need an object flow 5. So now we need the current value to come and update the previous value. I'm going to need another fork node, fork node 2, move the add a bit, integer flow 4. Now with that an object flow is our integer flow 5. Validate model. We have an issue here. So we have an issue of upper bound. This guy, integer 1. Validate model. Let's try this guy on the fine. Integer 1. Validate model. We're all good. To execute this model, we're going to go to our active class, go model utilities, we generate factory. We should have a factory. There it is. Into debug configurations and say new configuration, run Fibonacci synchronous. We need to add our model. It has found our class, apply, bug. I should have saved things, and this model runs for a little bit. Now what I just need to do is run configurations. We just run it again. Ready to add a new behavior, new child activity, a behavior for iterating, loop behavior is going to have an activity diagram, loop behavior activity diagram. We need to read ourselves. So here is a read ourselves. What are we going to call it? This is set the initial values. Have a look at this guy. Remember, here's a way of setting current. Copy it, paste that one, and we also going to need to give an initial value to previous. Edit, copy, edit, paste. And we're going to give it values for some constants. Value specification action. First one, we're just going to call it 1. And the value that we want for 1 is a literal integer 1. Put an edge, integer flow 1. Value specification action 0. By the way, it has to be 0, so we have to put this here. Integer. The integer 0 coming down. Integer flow 2. Organize a little bit. Fork or object. Object flow 1 is the very first one that happens here. Flow 2. Object flow 3. want to know that both activities terminate. So in the edges now we do a control flow from here to here. Control flow 1. Control flow 2. Now we're going to have to loop around. We need a merge node. And it gets triggered by a control flow from here to here. Control flow 3. We're going to need a copy of our object. And copy, because we're going to activate it and run a function on it. So we paste. Let's call it this. Yeah, control flow. Control flow 4. We need a node which is a call operation action. Our operation increment Fibonacci. Let's call it increment Fibonacci. Control flow back to make a loop. Control flow 5. And now we need our object flow. Check if we have any issues with the model. We have issues of bounds here. Let's make sure that this is a literal integer set to 1. Validate model. In this part here, properties, undefined bound. Make sure that they're all 1. Let's just close this. Alright, and it didn't show up, so we're almost ready to run. Class diagram. Open. Go into the class, go into advanced, and now we're going to change the classifier method to be the one with the loop. Here, put a breakpoint, the book configuration, bug. Oh, I should have saved everything. Okay, we have an error here that this is not connected. Go to the debug, stop it. We need an object flow. File, save all, run, configurations, debug. And we are in the debug state, so I can go to the debugger here. Drag some context, look at the variables. Right, so there's 0 and 1. Let's continue. This time, the variables are 1 and 1. Let's run it again. Because now this one has reached the value of 2 and 1. One more time. And you get to see here that the next Fibonacci value is 3. One more. We expect to see the next Fibonacci of 5. And we get 5 and obviously 3. Last one. And now we have 8 and 5. Stop the Moka execution. And what I'm going to do is go back to Papyrus and rebuild the whole application, and in particular, let's try to remember this diagram. We're going to do it slightly different. So, new Papyrus project, Fibonacci, raise condition. Close the previous one. New Papyrus model, expand, delete this one, open, child, package, Fibonacci, raise condition package. We're going to have a class diagram. So Fibonacci active class diagram. Active class to be active property Fibonacci previous, and integer. So this is going to be Fibonacci current and integer private. We're going to have our operation increment Fibonacci. Class is going to have a new child, which is an on behavior, increment method, new diagram, activity diagram, increment activity diagram, rate selection, we call it this, fork node 1, object flow file stable, import a register package, foundation model library because we're going to need to add 2 integers, validate the model, class, bands, classify behavior, increment method, later we'll change it for the loop, file stable, validate model. So we need to go to our increment Fibonacci, and here we need some method, okay, file stable, validate model. There's no more error. I'm gonna go for a read structure feature action, but this time I'm gonna read the current before in UML. Read current. If we wait a bit, that is a read structural feature action. Object flow 3, new child output bit. The result, the structural feature we want to read is the current. Perfect. Build a diagram from the button. We need a add structure feature value action. Set preview. We're gonna have to fork the value of current. Fork now 2. The value of current coming here. So there's an object flow. The structure or feature that we need to update is the previous. Now here we need an input pin, and we need an edge, the integer current that now goes into previous. We need to replicate something, so I'm gonna go edit copy, edit paste, read previous. It should read the previous. File stable, object flow 2. Remember, we need a call behavior action. Call a behavior from the foundation library. Add. The current goes into Y, and the previous goes into X. We're just copying the previous time. The result has to be stored in current. Copy this, paste. The value comes from result to value. And the object that we are updating, we have the whole diagram reproduced here again. Validate model. We get an object flow with an issue of bounds. Bounds set to 1. Validate. Is all good. Could run this. Debug configurations. New configuration. Fibonacci raise condition. The model we're gonna use is our model. Apply. Debug. Save everything. We have exception. I have not generated a factory. Go to the bug configuration. Actually, what we should have here is the factory. Apply. Bug. Save. Our method now run. Our active class. new child activity, loop behavior, new diagram, loop behavior method. We go to the increment method, edit, copy, edit, paste. We need to set the current to 1, edit, copy, edit, paste. We need to set previous to 0, edit, copy, edit, paste, put a fork, object flow 1, object flow 2, object flow 3. Now we need a value specification action. Call that 1, integer flow 1, literal integer 1, edit, copy, edit, paste, integer flow 2, the integer constant is 0, file, save all, join node 1, control flow, control flow 1, control flow 2, control flow 3, so we'll call it this, control flow 4. Now we need our call operations action. Here, the increment Fibonacci. Control flow for the loop. And this is object flow 4. File, save all. In the activity class diagram, change the classifier behavior to the loop behavior. Save all. Have a look at the loop behavior. Run the bug configuration. Takes a while there, and then it loops around. You see in this diagram that we run. Stop this for a moment. Set a breakpoint. Run. Stop. But now the interesting thing, the Fibonacci numbers, they say 0 and 1. Continue the execution. Doing this, setting the previous before setting the current. Looking at the context, the Fibonacci numbers are 1 and 2. Run it again. And now the Fibonacci numbers are 2 and 4. It's a bit strange. We'll run it once more time. Now the Fibonacci's are 4 and 8. So something very weird is happening. This is because this is basically a race condition, and the way we built the diagram now with Papyrus Moka is emulating doing this part of the diagram before doing this part of the diagram. This shows you how risky it is to run something that should be a parallel computation and the full sense of security that the diagram is correct we had earlier from our first construction. Actually, the semantics of how Papyrus Moka interprets activity diagrams depends not only on the diagram but also on the order in which you build your components.